All right, so looks like a lot of you are less than an acre. The next is, oh, so there's a big gap, and now the next group of you is between 6 and 20 acres. So relatively small number of acres people are working. Okay, a lot of pretty new farmers. Good to know. And a lot of you, the majority of you, are working by yourselves. So okay, that's going to be interesting when we talk about some of the suggestions that I might have for how to manage different pests. But let's get started. I'm going to, here's the plan. I'm going to spend some time. I'd like to spend about half an hour on an overview of IPM concepts and practices, a few minutes on flea beetles and Japanese beetles, because Dan told me that they were an issue. He's heard about them being an issue this summer. And then I'm going to go and dive as deeply as we have time into tomatoes and cucurbit IPM practices. And before we do that, we're going to have another poll to ask you to prioritize the topics within those two crops that you'd like me to start with, and we'll just move through those topics until we run out of time. So I'd like to spend about half an hour on both tomatoes and cucurbit pests and IPM practices. And wait a minute. I guess I can't turn my video off. If one of you could turn my video off, that would be good, because I see I'm looking a little ghostly. So I'm going to talk about a whole farm IPM approach that I worked on with Andy Fellons, thank you, who is a farmer, a diversified fruit and vegetable farmer who recently retired, but he was also an educator with NOFA New York. And so I'm going to start with soil health, which maybe is not the first place you'd expect me to start with an IPM presentation, but that's where I start with my IPM practices. Talk a little bit about rotation, kind of general insect and disease management strategies, and then thinking about being prepared for the growing season. So soil health, especially if you're practicing, if you're farming organically, is fundamental, I think, to organic practices in IPM. And so the goal is to maximize soil microbial activity. And growers do that with regular additions of organic matter. Regular additions of organic matter means there's always some organic matter breaking down. And I'll talk a little bit more about why that's important in a minute. Also really fundamental to soil health is the presence of actively growing roots in the soil. So figuring out how to keep cover crops on the ground as much as you can, not leave bare soil, is also keep some of these microbial processes going throughout the season. And reducing tillage, of course, will help conserve organic matter and be less disruptive to the microbial activity in the soil. So if we think about soil organic matter, it's between about 1% and 6% of the total soil mass. And the bulk of the organic matter in the soil is humus, which is a very inert substance. It's really not interacting. It's good for soil structure in general, but it's not really interacting with the microbes as much. And then about 10 to 20% of the biomass is something that's alive: roots, bacteria, fungi, all those little amoeba and those little creatures that are in the soil. And then another 10 to 20% of the organic matter is what's called the active fraction. And really the active fraction is where the action is. That's organisms that are actively breaking down organic matter, colonizing roots. The surface of the roots is a very active place. And this is a microscopic image of a root hair that's been stained, and you can see that it's just covered with different bacteria and fungi. So the organic matter fraction contributes to soil aggregate stability just by the exudates and just by the bulk of the microbial organisms in the soil. And so having an active microbial community maximizes the root colonization by beneficial organisms. So you would rather have your roots be colonized by beneficial organisms than colonized by pathogenic organisms. So just those beneficial organisms take up actual real estate on the roots, and they're also competing with pathogens for the exudates, the carbohydrates that the roots are putting out into the soil. They're manufacturing antibiotics that are fighting off some of the pathogens. And another aspect of having your roots actively colonized by beneficial organisms is that helps induce the resistance mechanism in the plants. So the plants have kind of an immune response that is activated by being attacked by a plant pathogen or an insect, and being colonized by beneficial organisms, it turns out, either on the roots or even on the surface of the leaves, can help activate that system and have it ready before the pest organisms even get there. So this is just a cartoon about, it's called induced systemic resistance. It can be induced by beneficial microbes. It can be induced by insects chewing on the plants. It can be induced by pathogen infection on the plants as well. Just wanted to make the point that some of these root colonizing beneficial fungi have been formulated into products that can be used to help give your plants a boost. And I see these used most often in greenhouse situations, that a grower will mix these organisms or these products into their potting mix, or they'll drench the transplants before they put them out in the field. And so here are some of the species that, the beneficial fungi species that are in these products: Trichoderma, Streptomyces, and Gliocladium, and then the different products that they've been formulated into. And at this point, there are way more products than are on my list. So that's a way to give your plants a head start before they go out into the soil. Another really beneficial colonization that happens in the soil is mycorrhizal symbiosis, and you've probably heard about that. Again, they're colonizing the root surface and competing with pathogens. Mycorrhizae have a very direct relationship with the roots, in that there are structures that the fungi actually put into the roots, and so they're getting nutrients from the roots, and also delivering especially phosphorus to the roods. So that's what I mean when I say they liberate less mobile nutrients from the soil. That's especially phosphorus. And then again, they're creating with their hyphae, which is the thread-like organisms or structures that they put into the soil, and glomalin, which is a compound that they create. They're also increasing soil aggregate stability. And so again, this is just like a cartoon of what the benefits of mycorrhizal colonization are. On the left side here, you can see the volume of soil that can be exploited by just the root hairs. And on the right, you can see the larger volume of soil and more access to phosphorus that can be liberated and delivered to the plants that are colonized by mycorrhizae. So we talk about soil health. There's some other kind of soil health, plant health benefits to having a good, healthy, microbially active soil. So good aggregate stability and good water percolation can really help with pathogens like Phytophthora blight, which attacks cucurbits, peppers. Yeah, I guess those are the main ones I'll talk about, because the Phytophthora blight is favored by waterlogged soil. So if you have good aggregate stability and your soil is able to drain after a heavy rain event, which of course we're seeing more and more of, that will help prevent the conditions that favor Phytophthora blight. Other practices that contribute to good soil health are reducing tillage and traffic. Some growers are going to a permanent bed system, so they're actually never driving on their the beds on the soil that they're planting into. Another aspect of soil health is nutrient balance. It's good to have a good program of soil and or foliar testing so you can keep track of your nutrient levels and not get your nutrients out of balance, like especially having too much nitrogen can predispose plants to some plant diseases. Understand and possibly even test the nutrient content of the amendments that you're putting into the soil, and avoid the compost trap. And what I mean by avoid the compost trap is that especially when farmers are just getting started with organic farming, they're applying a lot of compost, and it's probably their main source of nutrients, and that makes a lot of sense for a number of years. However, what you want to avoid is using compost as your main source of nitrogen, because you'll end up with very high levels of phosphorus in the soil. And we've seen that with case studies on different farms that have been using a lot of compost for a number of years. So rather than thinking about compost as a source of nitrogen, you want to start thinking about your cover crops, especially leguminous cover crops as a source of nitrogen when you till them in. So especially for new farmers, I urge you to think about your rotation plan and establish rotational units. And that's going to be either a field, part of a field, a number of beds if you have a permanent bed system. But you want to think about how you're going to rotate your crops. And you want to think about rotating crops that share pests together so that you can rotate away from those pests, especially those pathogens, those fungal diseases, especially that overwinter in the soil. So usually we're thinking about rotating by plant family. And another thing I urge, especially newer farmers to think about, is to plan ahead about how you can maybe rotate out of vegetables every 3 to 5 years into a year of a cover crop. Because vegetable production can be really hard on the soil, and soils can get really degraded after a number of years of vegetables without any kind of break from that. And it's good to think about something like a grain crop that doesn't host a lot of the vegetable pests to take your vegetable land out of rotation into. Another important aspect of your rotational plan is to understand the host range of your pathogens. For example, early blight, which is a very common disease in potatoes and tomatoes, that pathogen only attacks potatoes and tomatoes. So it's relatively easy to keep track of, the hosts of that and rotate away. Whereas a disease like Sclerotinia white mold has a very wide host range, and it's more difficult to think about how, what your rotation is going to be to get away from hosts of that. Another thing to think about in your rotation is the influence of what's in the surrounding habitat. For example, there could be alternate hosts of some of the viruses that could attack that could infect your plants. And you want to also think about air movement for crops that are very susceptible to fungal diseases. For example, if you've got a field that's very surrounded by woods or just doesn't have good air movement, you want to think about the implications of that when you rotate a crop that has a lot of fungal pathogens into that field. And another thing about the rotational plan is that you need to keep in mind that some pests are not affected by rotation at all. So there are some diseases that don't overwinter here, like Cucurbit downy mildew, which I'll talk about later. And there are some insects that also don't overwinter here. For example, potato leafhopper, which has a very wide host range, but is mainly a pest in vegetables on potatoes and beans. Some insects are very mobile, like striped cucumber beetle. It's very hard to rotate far enough to get from them to get away from them. And I already talked about potato leafhopper having many alternate hosts. For example, hay fields are a host of potato leafhopper, and often at the first cutting of hay, potato leafhoppers will move into vegetable crops. So it's good to be able to keep track of, understand that life cycle and that host range, so you can be prepared for when they might be moving into your crops. This is a really good crop rotation guide, crop rotation on organic farms. You can download this from SARE at this point for free. So I would recommend that. It's really a deep dive into crop rotation, but especially if you're in the early stages of farming and still developing your crop rotations, this is a really excellent resource. Okay, Dan, did we ever get the poll questions about whether people were confident with their identification and management strategies?
No, now is the time for it?
Is it? Yeah.
Yep, we can pull it up.
I don't remember if we even did it now.
No, we can pull it up now though and have people run
Yes,
through.
I think now would be a good time to do that. And now would be a good time for, like, I'm moving a little bit away from some of the more basic stuff. If anybody has any questions about what I've covered so far, now might be a good time to do that.
Yeah, so Gina, if you would put up the slide 12 poll, and if folks have any questions in the meantime, please do enter them in the chat. We can address some basic questions now.
You have to give me 1 second for this,
Sure.
this slide 12. Thank you.
No problem. Yeah, it doesn't look like any questions on fundamentals.
Okay.
Just hold tight, everyone. You'll have another quiz question or two that comes up on the screen here, another poll question rather, to respond to, and that'll help us with directions here.
So I only have a slide 15. Is that the
Yeah,
one?
oh, that would have been the one. Yep.
Oh, okay, sorry.
I'm
That's
sorry.
what I was checking. No, no problem. Here you go. Nope.
Okay, great. Thank you. So I just wondered, I would like to know, it's useful for me I'd like you guys to answer this at right now and hopefully at the end as well, to see if it was helpful for you in terms of these questions to participate in this webinar.
Give it just another 15 seconds here or so.
Okay.
Looks like we've got about 2/3 of folks have responded.
Great. Thanks, everyone.
Okay, I would say that's probably good. That's 22 out of 27.
Okay,
so.
great. Okay, so it looks like more of you don't feel very confident identifying, and so that's good for me to know. But I'm glad to see that more of you feel like you have reliable resources. And I did make a handout. I'm not sure how we'll get that to you, but I do have a list of resources to suggest to you that somehow we'll get to you at the end of this, maybe.
We'll share that in the follow-up email. Yep. Okay,
great. Thanks, Dan. All right, so just launching into kind of the more IPM, what you would expect from an IPM presentation. For insect and disease management, I just feel like being able to accurately identify your pest is just really essential, and it just takes time and experience and sometimes some winter study and going to different webinars like this and any kind of workshop that you can attend to help you be able to do that. And I think, so not just accurately identifying your pests, but also being able to identify beneficials. And there's a lot of insects in your field that are just passing through. Only about 1% of all the insects in the world are actually pests. So keep that in mind. Try to keep track of what you would expect from that crop at that time of year. The guidelines that conventional growers use, if you look at the pest list and those kinds of guidelines, those are probably the most important pests in your state or your area. I also think it's important to understand pest biology, the life cycle of the pest, like when does it emerge? Does it have 1 or 2 generations a year? How quickly does each generation develop? How quickly does the population grow? What is the host range of this pest? We talked about that with potato leafhopper. Some pests just live on one host and some live on many. Where does that pest overwinter? Like, where are you going to expect to find it? Can you rotate away from it or not? What time in the season do you expect it? Some pests don't show up until mid to late season. And when I say epidemiology, I mean how quickly, especially for a disease, would you expect that disease to develop? For example, late blight of potatoes and tomatoes is a disease that could develop so quickly in favorable conditions that your whole crop could be dead in 2 weeks. Whereas early blight, which is a pest of the same crops, develops much more slowly and is not it's such an alarming pest. So management approaches are based on an analysis of pest biology to target vulnerable stages. I feel like organic growers and growers who want to minimize the amount of pesticides they use really need to employ every technique and every thought process that they can to try to outsmart these pests, reduce them to a low level, and reduce the number of times that a spray or an intervention is needed. So I don't know if you're familiar with Swede midge. It's a serious pest of cabbage and brassica crops that we've been dealing with in New York for about 10 years. But it's a very tiny insect. It's a weak flyer, and it overwinters as a pupa in the soil. So one strategy that a colleague of mine, Christy Hoepting, has developed is to try to crash the population of the Swede midge by avoiding either early or late season crucifers. So if you don't plant any early season crucifers where it's weak flying cannot get to it, like in a field far away, or just don't plant it early season at all, then you're kind of crashing that population. And then you can go ahead and plant late season crucifers that season. Or think about how far, if you can get far enough away from a pest. For example, Colorado potato beetle, when it first emerges, can only walk. So if you can rotate your crop that's susceptible to Colorado potato beetle far enough away from where it overwintered the previous season, you can either delay or prevent it from finding your crop the next year. For diseases that with a limited host range that overwinter in the soil, for example, early blight and septoria leaf spot, rotation is an excellent strategy for those. Another way that we can take the pest biology into account is that smaller immature stages of insects are more susceptible to insecticides than either larger insects or the egg stage. The egg stage of insects is generally not affected by insecticides. So if you're scouting and you're finding eggs, you probably want to wait a few days before you rescout and decide if you need to spray something for that.
Abby, there was a question about the
Yes.
effectiveness of cover crops with Swede midge.
So to prevent them from emerging, I wonder. I'm not quite sure.
I'm gonna guess it's probably for control.
Yeah. So for a pest that overwinters or that pupates in the soil, sometimes tillage. So if you would till and plant a cover crop, that might be something that would reduce the population. But I'm not thinking that, for example, if you direct seeded a cover crop without disrupting those pupae, that it would do a lot of good. So I hope I was going in the right direction with that question.
Yep, and do you have any pictures of the Swede midge?
I did not include brassicas in this presentation. I'm sorry.
That's fine.
But I can send Dan. There's a brand new fact sheet about that Christy Hoepting just created, that I can send him the link to that. We just got that posted on our collection. Does that sound
Great.
good?
Yep, we can include that in the follow-up. Yep.
Okay, great. So I would say, during the winter, I know that people most people are not as excited about pests as I am, but I would say that in the wintertime, when in your downtime, it would be a good time for you to study up on the pests that you should expect in the crops that you expect to grow the next season. So other ways that we can manipulate the system to thwart our pests is, of course, to choose resistant varieties wherever possible. That's much more of an option for diseases than insect pests. We want to think about doing things like minimizing leaf wetness by making sure we're using recommended plant spacing. Staking and pruning tomatoes is another way to minimize leaf wetness. And of course, growing in high tunnels. So the main benefit of growing in high tunnels is to eliminate or minimize leaf wetness, and that really eliminates certain diseases. I talked about distance rotation for Colorado potato beetle. And there's another thing that I'll talk about more, which is perimeter trap cropping that has been worked out pretty well for striped cucumber beetle, but could possibly be used for some other pests as well, but I won't talk about that now. Oh, here's a picture of it though. And this is just, this is a trial, so this isn't what somebody's field would actually look like, but the way a perimeter trap crop looks is this is for striped cucumber beetle, and we're trying to get the striped cucumber beetle to stay on this larger, more attractive perimeter variety of squash and protect the inner, more susceptible variety. That's what we want to sell. So that's the concept of perimeter trap cropping.
I mean, there was another question about the efficacy of row cover versus Swede midge.
Row cover is a very effective strategy, and not just the usual row cover, but it's called Protect Net. So it's a very stretchy, more porous row cover. Sounds like Swede midge has found Pennsylvania. I'm sorry that I didn't include that in my presentation. But yes, absolutely, row cover is a good strategy for Swede midge. So just another thing about just understanding your pest biology is seasonality. When would you expect your main pests to appear? So for example, cucurbit powdery mildew typically doesn't appear early in the season. It appears mid-season on heavily fruiting crops like zucchini or summer squash, so that you can use those as almost indicator crops that you would, scout first for that disease. Powdery mildew also develops under humid but not wet conditions, which is unlike many other fungal pathogens. And another thing to know about something like powdery mildew is early detection is essential, because once it gets started, it can really increase rapidly. So these are just kind of questions that I think I would, so I think what I'm trying to do in this early section is to kind of help you develop a thought process about your pests, because each farm is individual and different practices are not going to work on different, are going to work better or worse on different farms. So I think especially organic growers really, it's a good practice to try to work on developing strategies that work really well for your farm. I've got a dog who's bugging me, so you need to stop. Okay, sorry about that. And here's just a picture of powdery mildew, so everybody's familiar with what I was talking about. Another aspect of insect, kind of basic concept in insect and disease management is tracking and forecasting. There are tracking and forecasting sites for cucurbit downy mildew, for late blight, and for cabbage maggot. And I'll just quickly go through these because I'm going to talk more about these later. So usablight.org has reports of where late blight has been found in a given growing season. The CDM IPM pipe has both, again, reports of where cucurbit downy mildew has been found, as well as forecasts that can help you understand your risk for cucurbit downy mildew in the next several days. And then there are insect forecasts that are based on degree day accumulations, which is just a heat unit accumulation that can help you understand when a particular pest is going to reach its peak, so that you might want to try to avoid planting a susceptible crop right at the peak of that flight. So I just wanted to quickly touch on biological control. I could do a whole talk on biocontrol, but there's different approaches to it. So there's, think about, there's a lot of naturally occurring either introduced or native beneficial insects, and you want to think about how to conserve them. There's also the possibility of releasing insects that are reared in an insectary. And then you want to think about what the timing and number of releases are for that. You want to be familiar with that. And then another aspect of biological control is microbial pesticides. And so there's some fungal pathogens of insects that have been formulated and used similar to other pesticides. And then there are some microbial fungicides as well. And so we talk about conserving natural enemies. We're talking about minimizing pesticide applications as much as possible. Even pesticides that are allowed for organic can be harmful to beneficial insects. Use the least toxic materials that you can that are still effective. Provide pollen and nectar sources and provide overwintering habitat. And so overwintering cover crops can be a great overwintering habitat for beneficials. This is a vetch cover crop with 3 or 4 lady beetles that have overwintered in there and are feeding on the nectaries. Here's a farm in central New York, Blue Heron Farm, that has a permanent bed system with mowed laneways in between. And so even though they're mowed, there's a lot of flowering resources in there, and a permanent place for, an undisturbed place for beneficials to overwinter. And here's what I would call an inadvertent beneficial habitat, which is a wild mustard at the side of a potato field, but I'm sure there are a lot of beneficials in this, and the grower would definitely want to mow this down before it sets seed. And as that gets mowed down, that will move the beneficials into the crop. So again, so another thing to think about with winter work is to develop a set of what you expect, what pests will probably need some kind of intervention, either a release of beneficials or pesticide application, and kind of develop a plan for that. So what will the intervention be for that particular pest? What products are effective? Get those products and have them on hand, or be aware of when beneficials need to be ordered. Often they need to be ordered 1 or 2 weeks before you can get them and release them. So that's something to keep in mind if you're thinking about using beneficial insects. And how will the decision to intervene be made? Who will be out scouting or tracking the occurrence of these pests? Who will be in the field looking for them, or who will be on the websites keeping track of how close late blight is to you? And I see that a lot of you are working alone, so that makes it a little bit more difficult. If you have employees or interns, I think it's really good to cultivate 1 or 2 of your employees or interns to be your kind of pest management specialist, if they have an interest in that, and give that priority to at least somebody on your farm, because I know how easy it is to let that get away in the heat of the moment when you're harvesting and planting. And so another thing to think about is who will do the spraying. Yes, Dan, do you have a question?
Sorry, we had 2 questions here. Okay. One was to do with the treatment of powdery mildew and cucurbits, and wondering the sensitivity to copper and the efficacy of sulfur-based products.
Okay, I have a whole bunch of information on that, so we'll make sure that we talk about powdery mildew. Okay. That'll be one of the cucurbit pests that we talk about. Help me remember that, please. And there was another question?
Just will the slides be available afterward?
You're recording. Are you recording?
Yes, we are. Yep.
Okay, great. Yes, so that's how they'll be available, right?
Okay, via the recording. Okay.
Yes. Yes. Yep. Okay. Is that it?
That's it. Yep.
Okay. Okay. All right. I think I finished that. So I just kind of, to recap, the kind of universal basic concepts is really important to understand your pest biology and think about ways to manipulate your systems that you develop to target vulnerable stages of your pests. So understand the host range, where they overwinter, what season to expect them, and how quickly they develop. And then be prepared to deal with them. Assign responsibilities for monitoring, either by scouting or monitoring, tracking or forecasting websites, and have the products and equipment available when you need them. So when I talked to Dan last week, I guess, he suggested that this year was a pretty bad year for flea beetles, and that might be of interest to people. So I'm going to do a short little flea beetle presentation. And so flea beetles are tiny little black jumping beetles, and they're most often seen on brassicas, and that's the Crucifer flea beetle and the striped flea beetle. And they're also seen on solanaceous crops like eggplant, especially eggplant, and potatoes. And that could be either potato, tobacco, pale striped, or eggplant flea beetle. And so here's what the Crucifer flea beetle looks like, the striped flea beetle. And this is the kind of damage that you see from flea beetles. And this is about their size. They're just tiny little beetles. They have large back legs, jumping hind legs, and they jump like fleas. And they dig little pits in the surface of the crop. And then as the leaf expands, sometimes that rips into larger holes. And similar damage on eggplant, just tiny pit-feeding little holes. And so the life cycle of the flea beetle is that they overwinter as adults, and insects that overwinter as adults can be a real challenge, because if you don't have an effective insecticide to really knock them back, there's little that you can really do to kind of get away from them, because they're pretty mobile. So they colonize the plants, they feed on them, and then they lay their eggs at the base of the plant. And then the larvae feed on the roots. And then there are either 2 or 3 generations a year, maybe possibly more in southern Pennsylvania. But anyway, it does tend to be true that the overwintering generation, or the first ones to come out, do tend to cause the most damage. They're kind of the most concentrated in time. So for Crucifer flea beetles, both of those species feed on a variety of different vegetable and weed species. So because they're out feeding on weed species, it's more difficult to kind of manage them and control them through rotation on your farm. They are more attracted, their feeding is stimulated by mustard oil, so they're more attracted to the spicier crops. You've probably noticed this. Arugula and mustards are much more highly damaged than something like broccoli or cabbage. And here's just an example of that. This is a trial where we were looking at maybe the possibility of using glossy collards as a trap crop for flea beetles. And this is right in the same row. This is the amount of damage on glossy collards compared with cabbage, the same flea beetle population. So flea beetle, again, are one of the more difficult insects to control or to manage on organic farms. And the strategy from my perspective will depend on the plant part that's being consumed. If you're trying to get seedlings or transplants established and you just want to keep them growing well and you don't really care if there's a little bit of damage, that's one thing. But if you're trying to protect leafy greens, that's a whole other story. So if you're just trying to get plants established, you can try to rotate, again, away from where you had a lot of brassicas last year. So another reason to try to group your brassica crops together as much as you can. Keep your plants growing vigorously. Plants that are growing weakly or are wilted are much more attractive to flea beetles. For insecticides, Galen Dively, who has done a lot of work with organic insecticides down in Maryland, has found that Entrust, Azera, and Pygamic performed equally well, but not really that well. So they're certainly not going to be able to prevent damage to something like leafy greens, and you don't really want to be spraying leafy greens anyway, because you're going to be marketing them. So I think for protecting leafy greens, row cover is really the only good option if you're trying to avoid cosmetic damage. So you want to plant them and cover them immediately before any flea beetles get in there. You want to seal the edges as well as possible, and you want to recover them immediately after cultivating or Of course, one downside to row cover is that weeds can really get established under there. So you want to think about any way that you can minimize your weeds before you put that row cover over will really help. And don't plant a second crop where that earlier crop was harvested, because remember the larvae are feeding in the soil, and you don't want to put row cover over where you had where they're going to be starting to emerge, because they'll be very happy under there under your row cover. They'll thank you for it. So another pest that Dan mentioned was Japanese beetle, which has a huge host range. So this is obviously something that you can't rotate away from, and I've noticed that it's something that some years it's really bad. It's pretty bad around here this year too. So the larvae are pests of your lawn and the kind of sod, and so it's difficult to treat the larvae because they're just such large areas of sod and lawn to treat. And especially if you're trying to farm in a suburban area where everybody's got those big lawns, that can be a problem. I've had people tell me, I always recommend that if you're going to trap for Japanese beetle, that you buy the traps and give them to your neighbors, that you don't put them on your farm, because they really do draw Japanese beetles in from a large area. But I have a couple growers, so I'm just sharing that with you, who said, yes, I trap them, and then I take the bucket and put it in the freezer, and I feed them to my chickens all winter. The chickens love them. Another gardener told me that she put a trap in the middle of her pond, and then she cut the bottom off the bag, so they go into the trap, they fall into the bag, and they fall into the pond, and the fish eat them. So there you go. That's what I know about trapping. For insecticides, again, this is Galen Dively information that I forgot to attribute to him, but he found that azadirachtin or neem products appear to have a repellent and feeding deterrent effect. So in his trials, azadirachtin or neem products seem to do the best against Japanese beetle. Okay, so now I'm going to launch into kind of a deeper dive on tomatoes and cucurbits, and now would be the time to put up the tomato poll so that we can rank which of these topics people are most interested in. Then we'll go through them in that order until we run out of time. And Dan, I don't know where I put my phone, so I don't have a clock here. Could you let me know what time it is?
Yep, it is 7:45. So we'll just split the time down the middle here. I'll give you about 22 minutes, and then we'll do the next one. Mm-hmm.
Yep, that first part took longer than I wanted it to. All right.
All right.
Okay, so it looks like we'll start with fungal diseases for sure. Then it looks like we'll go to late blight. And then it looks like we'll go to bacterial diseases. So this is going to be all diseases all the time. All right. So let's start with fungal diseases. End poll. Okay. So there are some very common, I forgot to put in anthracnose, so I'll talk about that. So it will, so early blight, I would say, is the most common fungal disease of tomato. It's relatively easy to confuse with some of the bacterial diseases and septoria when they're small. The early symptoms are just small, dark lesions. But as the lesions get older, they start to develop this target appearance. Another characteristic of early blight is that it tends to be bound by the leaf veins. So the leaf veins tend to stop it, and so you end up with not necessarily round lesions. So the early blight is first seen on the older foliage. It's going to be splashing up on onto the lower leaves from the soil, because that's where it overwinters. So this is definitely one of those fungal diseases where rotation is important and can be very effective. But keep in mind that early blight, both potatoes and tomatoes are hosts for this early blight, this pathogen, this fungal pathogen. So you have to keep that in mind with your rotation choices. Of course, septoria and early blight can appear together. Often they appear together. This is not late blight, this photo on the left. This is both early blight and septoria in a very favorable season. And you can see that this farmer did everything right in terms of mulch to keep the soil from splashing up onto the plants, staking and staking to try to keep the leaves drier. But in some very favorable rainy seasons, you could really get a lot of damage from septoria and early blight. So again, rotation is key. Staking and mulching are both key. And I would say pruning, if you can get in there and do any kind of pruning, because you can stake those tomatoes, but they could still be really thick if you don't try to prune some of those lower suckers off. I understand that that takes a lot of time, but I know if you have the labor and the time to do it, it's well worthwhile. There are some resistant varieties for early blight and septoria. They're not that common, and I don't know how commercially available they are. They're kind of still under development. But this early blight and septoria are ideal situations where high tunnels are going to be very effective to keep those leaves dry and really almost eliminate early blight and septoria. And I forgot to talk about anthracnose, which is, I'm sorry I didn't remember to include that, but that's a disease of the fruit that causes sunken dark lesions on the fruit that eventually get some sporulation in them. And again, that overwinters in the soil and is managed very similarly to early blight and septoria. So in terms of these fungal pathogens, there are some fungicides that are allowed for organic production that are, we've found some that are moderately effective. I've done some trials collaborating with Chris Smart at the Cornell Agritech in Geneva. And so unfortunately, the coppers are the most effective ones usually, but actinovate, double nickel, and regalia have also been moderately effective. Some that we've tried that were not effective against these fungal pathogens were oxidate and serenade. I wanted to talk to you about some tomato disease forecasting models that I'll show you more about them later when I talk about late blight. But I just wanted you to be aware of this nua.cornell.edu website where you can get pest forecasts, and tomato disease forecasts are one of them. So I'm going to go to leaf mold now because that's another fungal disease, and that's a high tunnel disease that I think since I've been recommending high tunnels for these other diseases, I should really talk about one of the downsides of high tunnels, which is this: high tunnels can really favor this tomato leaf mold, which is, this is the underside of the leaf. You'll see this olive green kind of a fuzzy sporulation on the underside of the leaf. On the top of the leaf, you'll see just yellow areas, and those yellow areas correspond with this fuzzy olive green sporulation on the bottom of the leaf. So this pathogen grows best at high relative humidity. So any way that you can use fans or vents or keep the sides rolled up to reduce humidity in the high tunnel is going to be really important. Space the plants as much as you're able to increase air movement in the high tunnel. And again, trellis and pruning to increase the airflow in and around the plant, just to decrease that humidity level around the plant. You want to remove and get rid of any crop residue that was infected at the end of the season so that doesn't carry over in the high tunnel. Sterilizing any trellising stakes or any other equipment that comes into contact with the plants in the high tunnel. Commercial sanitizers that are allowed for organic are Sanidate and Zerotol. They do work well. And you want to think about maybe cleaning and sanitizing the high tunnel walls at the end of the season as well. There are some resistant varieties. I can show you some results of a trial. And there are, there are some effective fungicides for both conventional and organic control. I'll talk about some organic ones. So this is a trial that Chris Smart did in 2018, looking at different tomato cultivars and their susceptibility to leaf mold. And you can see that there's a lot of, a wide range of susceptibility and resistance to this. And I think they were using this BHN 589 as a susceptible control. So that you can see Big Dina, Charger, Frederick, Primo Red, Red Deuce, Red Mountain, and Sun Peach were all significantly, had significantly less leaf mold than the standard control. And this is just a leaf mold trial in a high tunnel with different fungicides. So here's the untreated control. And this is the area under the disease progress curve, which is a common way of measuring accumulation of disease over time. It's just you take the amount of disease 1 week and do a calculation with it either like over 3 or 4 weeks. So it's a way to kind of quantify disease accumulation over time. So you can see here's the untreated control. Champ, which is a fixed copper fungicide, double nickel, Regalia and Zonix. I would say Champ and Zonix were the most effective products. Double nickel and Oxidate were the next most effective products. This BW165N is not a commercial product yet, but it's a biocontrol fungus that I'm hoping will be a commercial product at some point. And then Oxidate did have some effect, but wasn't one of the most effective products. Okay, so next, late blight was the next one, right, Dan? The next most requested?
Mm-hmm.
Okay. Luckily this season, knock on wood, I don't even hardly dare say this, but I don't think late blight has been reported in either Pennsylvania or New York. Does anybody know? Type if I'm wrong, if it hasn't been reported to me yet, anyway. So late blight was 30 years ago when I was taking plant pathology was thought of as a fungus, but we now call it a water mold, and we put it in a completely different category. So again, the early symptoms are just, this is what the bacterial diseases, early blight or late blight are going to look like early. You can't really tell what they are. You just have to keep in mind, okay, I'm seeing little black dots on my leaves. I need to keep an eye on this and see what they develop into, because you're going to want to see more developed lesions before you can actually identify it. But early blight, unlike late blight, creates these large, roundish lesions that go right across the leaf veins. And then they grow very rapidly, and sometimes they create a very unpleasant rotting potato odor. I worked with a plant pathologist for the first summer after I graduated working on late blight, and it was difficult for me to eat potatoes that summer. One very characteristic aspect of late blight is kind of some light white sporulation on the bottom of the leaf. And late blight attacks leaves, fruits, and stems. So that's another characteristic of late blight versus especially septoria and early blight. So this is that sporulation I was talking about. It's not very fluffy, it's not very long, it's kind of fragile looking, but what this is hundreds of thousands to millions of late blight spores that develop under high humidity when the humidity is over 95%. And then as the humidity goes down after sunrise and get some light, these sporangia pop off their little structures, and then they go floating off into the air to infect other plants. So especially if the weather is continually humid or wet, that allows the spores to travel further before they're destroyed by UV light. And it also creates more favorable conditions for them to infect the leaves that they land on. So that's why late blight is something that if you don't notice it and it's out of control, or if it's completely out of control in your area, it's gonna be almost impossible to control it on your farm. So one thing to know about late blight is that it only overwinters in living potato tubers at this point in the United States. So it can get through in seed tubers. You could purchase it in your seed tubers. So always try to purchase both phytosanitary certified seed that will minimize the amount of late blight that could be in your seed tubers. The other place it could come from is cull potatoes from the previous season that didn't die for some reason, cull potatoes in compost, or volunteer potatoes from the previous season that were infected. So if infected tubers germinate, here's that infection is going to come up the stem and start sporulating, and then it's going to start spreading to other plants. And so during the summer, there's this continuous cycling of sporulation and reinfection. And then those spores get washed into the soil, and that's how the tubers get infected in the fall. Oops, I always forget that this has animations. All right. So in terms of managing late blight, here is a website I mentioned earlier, usablight.org. It has a map that tracks where late blight has been found in a given season. You can also sign up for alerts on this website. So there's a place where you can click and sign up, and you can get either text or email alerts, and you can specify the area around your farm that you want to get alerts from if late blight appears in that area. And then I talked about earlier about there are tomato disease forecasts when I was just talking more generally about IPM concepts. So there are disease forecasts for one called Tomcast for early blight, septorial leaf blight, and anthracnose. There's one called Blightcast that can be used to time the first fungicide application for late blight, and there's one called Simcast that can help you time subsequent fungicide applications for late blight. And I didn't talk about bacterial diseases yet, but if you're aware that bacterial diseases are kind of endemic on your farm, these forecasts for fungal diseases might not be sufficient to manage your bacterial diseases with like a copper.
We've got about
So
5 minutes.
I'm sorry, go ahead. Yep.
We've got about 5 minutes left in the tomato section here.
Okay, I think I can just finish the late blight section, then we'll move on to cucurbits. Thanks, Dan.
Yep.
So I mentioned this website earlier. This is a website that was developed and is managed by the New York State IPM program. And there's various pest forecasts under these various disease forecasts and insect forecasts under the pest forecast menu here. And I just wanted to show you just give you a little taste of what the tomato disease forecasts look like. You select a weather station. So this is, I pulled up where weather stations are in Pennsylvania. This is, the forecasts are based on, usually they're based on temperature and hours of leaf wetness or hours of relative humidity above a certain level. So for this particular forecast, the question is this your first fungicide application, or have you already applied a fungicide? And then it's going to just fill in the current date. And then you would just hit results. And this is the kind of results that you would see. I had actually indicated that I had already applied, pretended I'd already applied a fungicide on August 11th. So, and I did that, yes, I did this morning. And so it had been 7 days since my last fungicide application. And for Biglerville, one of the PSU research stations, I think, you can see that in less than a week, this Simcast forecast that indicates favorable weather, how favorable the weather has been for late blight, indicates that the red shows that it's already over threshold. And so I would have wanted to check this forecast several days ago so that I could see what day that the weather forecast predicted that it would go over threshold. This Simcast also models fungicide weathering. And so you can see from a fungicide weathering perspective, the model indicates that there should still be some protection from the fungicide. So anyway, that's just, I don't have time to go through much more of that, but that's just gives you a taste of how that would work. So controlling late blight, there are some really highly resistant varieties in tomato, not as much in potato. Scout, know when disease is in your area. Don't wait until you find late blight on your farm. Preferably, you are not the first person to find late blight in your area. Unfortunately, coppers are the most effective fungicides. I wouldn't recommend messing with any of the alternative fungicides in a really favorable season. Try to use the forecast if you can, if you have close by weather data to time your fungicide applications. And if you have late blight, it will spread quickly to other plants under favorable conditions. So remove or destroy infected plants if you're able to. At some point, you may need to, unfortunately, I would say if you've got 10% or more of your leaf area infected by late blight in an organic situation, you're probably not going to win the game. Okay, so what am I going to do? Could you put up the Cucurbit? Oh, do we have a minute or so for any tomato questions? Are there any?
Sure, we could do a minute of tomato questions. Yep. For anyone in the chat box? No tomato problems this year?
Wow.
I hope that's the case. All right, last chance. All right, Gina, do you want to do the Cucurbit poll? All right, same as before, folks. If you can respond with topics that you'd most like to hear about.
Dan, am I sharing my screen right now?
Not right now, it doesn't look like, no.
Okay, I can't get the share screen command to come up. I don't know what happened. Let me go.
Okay, let's see when we close the poll out if that makes a difference.
So squash vine borer, powdery, downy. Okay. Okay, so we'll do squash vine borer first. Then we'll talk about powdery mildew and downy mildew on a dead heat. Okay. Let me close this. And let's see if I can get the screen sharing to come up. If not, I'm going to have to do a... Darn it.
Is it not showing up as an option at the bottom?
No, I'm scrolling around the bottom and it's not showing up as an option. Oh. I'm not sure. Do you have recommendations for what I should do now? What I did was I got out of, I can't get any of my doc to come up at the bottom.
So hover over see if it's at the top. Just run your mouse over.
Okay. No.
Let me try something.
Let me see what there's a couple. What's that? Okay, I didn't want that. And
so give me 1 second. I'm gonna remove you as co-host and then I'm gonna re-add it and see if that works. See if you'll see something now.
If folks in the meantime,
try it again.
We're working on this. Want to put any Cucurbit related questions in the chat box? We can start collecting those as well.
Yeah, I am scrolling at the bottom. I'm hovering at the bottom. I could try, I'm hovering at the top, darn it. All right, I'm gonna try ending the show. See if I can, okay, get back to Zoom. All right, share screen. Okay, hang on. I think I think I can do it. Let me just get to the Cucurbit part here. Okay, are you seeing that now?
Yes, it's coming through.
Yes. All right, sorry about that. Okay, so we're gonna start with squash vine borer. Was that true?
Correct. Yep.
Okay. All right, so squash vine borer. I have seen some, especially this kind of smaller acreage farms that I feel like I saw are prevalent with our audience have developed, some of them have developed some really some serious squash vine borer problems. So squash vine borer is actually a Lepidopterous pest. It's a clearwing moth. I can show you a picture later. It overwinters as a pupa or a larva in the soil. They emerge as moths when about 1,000 base 50-degree days have accumulated. And that's going to be different in Pennsylvania than it is here. Up here, it's late June, early July. So if you have so again, degree days are just a way to measure heat accumulation. And there's a lot of different sources to find out degree day information, including that NUA website that has the pest forecasts. But there's a biological indicator of that as well. If you keep track of chicory, which is a blue flowering weed, that 1,000 base 50-degree days does tend to correlate with the first flowering of chicory. So then the females are active for about 3 weeks. They're out laying eggs for about 3 weeks. And then the eggs hatch, the larvae bore into the stems, and they destroy the vascular tissue, and they cause wilting. So in a year like this, I don't know, it's been really dry up here. I don't know about Pennsylvania. I think you've had more rain than we have had, but it's going to be especially obvious in a really dry year. And of course, bush type cucurbit plants are going to be more impacted by feeding than vining types of plants, because the whole plant will just die if there's a lot of feeding. So this is what the eggs look like. If you were to scout for the eggs, and I have scouted for the eggs in my garden, it's not really a feasible thing to do. I think it's much more feasible to follow the degree days or follow the chicory flowering, but they're just little flat reddish brown eggs that are laid at the base of the plant. And then the first indication that you've got squash vine borer boring into your squash stems is they feed inside and then they push the frass out. And frass is just the scientific name for insect poop. So this is the insect poop that's pushed out of the tunnel, and that's how you know they're in there. And then if you cut the stem open, this is what you find. It's a grub, a big kind of fat white grub with a dark brown head. So different types of squash have different levels of attractiveness to squash vine borer. So like the blue Hubbard types are the most attractive. Zucchini is really quite attractive as well. Summer squash are pretty attractive. And then butternut is really not very attractive at all. So that kind of tells you what I would say probably in a fresh market diverse situation, your zucchinis are probably going to be almost your indicator plant for squash vine borer. So we did do some trials, and we were successful at learning how to manage squash vine borer in an organic situation. We found that a BT product, one of the BTs, the Izawi strain, and Agree is a brand name for that strain that includes that strain of Bacillus thuringiensis, which is a microbial insecticide, was most effective in our trials. Entrust, which is a spinosad product, was also effective. And what we did was we made 3 applications, each 1 week apart, starting at the beginning of the flight. We actually, there's a pheromone trap that you can use for squash vine borer, and we used that to determine the start of the flight. You can also keep track of the growing degree days, base 50, or you can monitor the first flowering on the chicory. So what I noticed on the farms that were developing a pretty bad squash vine borer problem is that they tended to abandon plantings of zucchini that they weren't done harvesting. And so that allowed the squash vine borer to complete their pupation, go into the soil, or complete their development, go into the soil and overwinter. So any way that you can avoid, so if you're done harvesting a squash planting, a zucchini planting, if you can get in there and mow it down really close to the ground, that would be well worth your while. And I somehow seem to have managed to skip over my photo of the squash vine borer adult, which is really a very attractive insect, but you'll have to Google it. Okay, so I think powdery mildew is where we'll go next. I would say this is the most common fungal pathogen across a lot of different types of cucurbits. I would say it's present every year. There are some decent resistant varieties available in a lot of different categories. For example, cucumbers don't seem to get powdery mildew, but there are some resistant pumpkin varieties and squash varieties that you can give them a try. So powdery mildew, it just looks like there's somebody dropped talcum powder on the top surface of the leaf, and the same appearance on the bottom surface of the leaf. So you can get these powdery mildew lesions, and it really just grows on the top surface. It sends little structures down into the plant cells, but it doesn't really grow into the plant and kill tissue like some of the other fungal pathogens do. So it can cover the whole upper and lower surface of the crop, and then that can impact fruit quality because it's interfering with photosynthesis. And this is a disease that really develops pretty rapidly if the weather conditions are favorable. And the favorable weather conditions are, again, not wet leaves, but high relative humidity. So detecting powdery mildew early is really essential. So what you want to do is start scouting weekly, especially on your zucchini and summer squash, because those are the crops that are going to set fruit first, and they're going to show the first symptoms of powdery mildew. So the way you want to scout is to look at 5 older leaves at each of 10 sites. Again, these recommendations are developed for like large acreage fields, so you'll have to, you're going to want to adapt them to your own situation. But the threshold is if you find 1 lesion of powdery mildew on 50 leaves, and often you find it on the bottom of the leaves first, that is when we're going to recommend that you start spraying so that you don't get a big, you don't get powdery mildew covering your whole leaves. So, so the question is, if you see it first on zucchini, are you going to do you want to keep harvesting that, or do you want to move on to another planting and kind of destroy that? And so you would want to destroy that crop so it won't put out more powdery mildew spores, and also for squash vine borer if you have it. And so the question about whether you want to spray for winter squash is how close to maturity is the crop? I mean, if your crop is almost finished and mature and you're starting to see powdery mildew, then I would say probably not worth it. But if you're starting to see powdery mildew and your winter squash or pumpkins are far from maturity, then I would say it's probably worth thinking about spraying some kind of a fungicide. And powdery mildew, I would say, is one of the more easily managed fungal pathogens in organic situations. So we've, in our trials, found, again, working with Chris Smart, found several active ingredients that have been effective. So plant activators like regalia and actinovate have been effective. Potassium bicarbonate products like millstop and calagreen. There's some oils, there's several oils that are effective. JMS stylet oil and organocide are examples of that. Sulfur is, I would say, the most effective product we've used, but sulfur is kind of nasty to use for whoever's working with it. So there's that drawback. In our last powdery mildew trial that we did in 2019, we found a new product, a citric acid product that's called Super Safe, that was also effective. And so because you have some different products that you can use, I would recommend rotating at least a couple of products, alternating them when you spray. So this is our 2019 powdery mildew trial. Again, I was working with Chris Smart at Cornell Agritech on this. And here, again, we're looking at the area under the disease progress curve. So higher numbers mean more disease. And here's the untreated control. And again, the sulfur and the Super Safe were the best products in this trial. Trilogy is a neem oil product that also looked pretty good in this trial. And then these other products were not, I guess, were not at the top of the heap. And again, here's a trial from 2016 looking at some different products. Here is the untreated control. In this trial, Millstop, Regalia plus Actinovate, and Sulfur were our most effective products. All right, let's try to get some downy mildew. Oh, here's Chris Smart, who has provided a lot of the photos that you've seen and a lot of the data that you've seen in this presentation. So Cucurbit downy mildew attacks all cucurbits. There's different strains of the pathogen that attack different types of cucurbits, but I would say that cucumbers and melons are the most commonly infected crops. The first sign of cucurbit downy mildew is a yellow, angular yellow area on the top of the leaf that eventually will turn brown and die. And then on the underside of the leaf, right under the yellow areas, you'll see a grayish purplish sporulation. That's the sign of the fungus growing through the surface of the leaf. So this is a young lesion. And then what they look like when they develop. Here's some younger lesions, and then, like I said, they turn brown as they get older. And then on the bottom of the leaf, you can see the sporulation on the lesions that are not brown and dead yet. So again, the life cycle is, this doesn't overwinter up here. I don't think it overwinters in Pennsylvania either. That's probably going to change over the years with climate change. But what happens is that spores start to come up from the south as cucurbit crops are planted. And we also, especially in Western New York, we get spores coming in also from Michigan some years. So the spores are produced on the other side of the leaf. They break off, they get blown to healthy plants. They hatched. This is a disease that is favored by wet leaves because it's kind of it has a swimming stage of its spores, and then those spores infect the plant and cause the symptoms. So again, this is what powdery mildew looks like. A lot more. This is the coverage. This is what we're trying to avoid. So the mildews. This is powdery mildew. This is downy mildew. Totally different pathogens. Okay, so I talked about it not being there are some commercially available resistant cucurbits. You should really look for any kind of resistance that you can find. There's a breeding program at Cornell and Michael Mazurik's lab that is looking at disease resistance to downy mildew. And again, you can sign up for alerts on this website, this CDM IPM pipe website. The same way that I talked about, you can sign up for alerts for late blight, either text or email alerts. So the other thing that this downy mildew website can do, this was last Friday, is it can show you the risk of infection and or pathogen spread into your area for like a 3 or 4 day period. So in addition to the alerts, you can go to the website and look and kind of look at what the risk is of the both the favorable weather and the risk of having inoculum coming into your area. So I just wanted to show you some, this is I'm pretty sure this is a variety or under development from the Missouri lab to show you the level of the difference that a resistant variety can make. So this is in the same farm. This is Brian and Jenny Caldwell's farm near Ithaca. And so neither of these had been treated. So this is Marketmore 97, which is just a regular susceptible variety compared with this DMR 401. I don't know what the fate of this is. This was a couple of years ago, whether this has been a named variety or not at this point. But I think there's some good resistance coming in the future. So I would say, so we've done trials against downy mildew, and I would say the most we can get from the trials, the most we can get from spraying cucumbers is 2 to 3 additional weeks of harvest. There's really not a very effective fungicide against them. So some growers are just giving up on cucumbers after August. High tunnels can provide some protection, just regular high tunnels. There are products available. I think, yes, I'm going to talk about this really cool spore exclusion high tunnel that a grower in central New York, Lou Lego, invented, because he's an engineer, inventor kind of guy. You can learn about this on the SARE website. You can read his reports because he got SARE funding to develop this. So what this is a regular high tunnel with a bank of HEPA like filters that are small enough to filter out downy mildew spores. And he's got air moving through these filters, and he's got a positive pressure on the other end. So when he opens up the door, air moves out instead of moving in. So he's ventilating his whole high tunnel using this air from this HEPA system. And here's just a closer up look at that. It's a thing. You know, you need additional ventilation and fans, but it's just regular HEPA filters that you can buy, furnace filters that you can buy at the hardware store. And here is Lou Lego. And so he had me collaborate with him on his trial, and he had cucumbers growing in the field, in a high tunnel, and in his spore exclusion high tunnel. And of course, downy showed up in the field first, and then it showed up in the regular high tunnel that without the filtered air, and it never appeared in the filtered air high tunnel. So, you know, it is kind of an engineering thing, but if cucurbits, and especially cucumbers and melons, are an important part of your crop mix, then, you know, it's worth thinking about. So yeah, there's a lot of information on the SARE website, funded project reports. So we have done a couple trials. What we tend to do is spray every 7 days for 3 or 4 sprays. Here's some of the products that we've tried. Zonix is a biosurfactant, some copper products, some microbial products, Regalia and Actinovate. Regalia is a plant extract product. Actinovate is another microbial product. These are both what we would consider to be plant activators. They need to be applied a week or 2 before infection is present. So this is our trial from 2018. Again, we're looking at area under the disease progress curve. And this is the untreated control. You can see that we're just not as effective. We just don't have products that are as effective against downy mildew as we had against powdery. But the coppers and Zonix do tend to be our best treatments. I think I have one more trial. Again, 2016, here's the untreated control. Tried double nickel, Champ, Regalia. This is called Stargus now, MB110, Regalia plus Actinovate. All were not significantly different from the untreated control. And in this trial, Zonix was the only one that was significantly different. And again, we just didn't have the type of control that we were seeing with the powdery mildew control products.
Abby, it looks like we're up against time.
Okay.
Maybe one last point, and if anybody has any pressing last-minute questions they want to include in the chat box, we can address 1 or 2 questions here.
Okay. All right. Thanks, Dan. So when to start spraying for Downy? I would say start spraying before you actually see it in your field, which is why that website where you can track where Downy has been reported is important. It's also important for you to collaborate with if you have a local extension person and you think you have Downy, collaborate with them so you can either report it yourself or collaborate with them for them to confirm it and get it reported on that website so other people will know. So start applications before symptoms appear, and that's especially important with the plant resistance inducers. And that was all I had for Downy, actually. And thank you for helping me prioritize these topics, because obviously there's no way I would have gotten through all of them. And so yes, please, if there's a little more time for questions, I'd be happy to try to answer them.
Yep. If folks have any pressing questions, the chat box is the place for it right now. The other thing, as we mentioned, we'll be sending out a follow-up email with links and attached documents for things that were mentioned tonight. So you can keep an eye out for that. We will also probably wait until this recording is processed and posted so that you can use it for reference as well. So that usually takes a few days to a week. So you should be receiving that, in the next little bit. Also, Gina will be posting a final eval quiz, I believe, in the chat box, and we'll also be putting that in the follow-up email. Please do fill that out if you can. It helps us with grant reporting and event planning and all of that sort of stuff, making our programs better. Abby, for you, Anthony asks, the funding for the high tunnel with the filters, where did that funding come from?
That funding came from the Northeast SARE program, and it wasn't funding for, it was more funding for the research to see if it worked than it was to give somebody money to build a high tunnel. I don't know if NRCS programs for building high tunnels are still active, but there was some federal funding through USDA for high tunnel production that you could get at least part of your high tunnel funded through that.
Yeah, I believe the EQIP program is still funding tunnels, at least in Pennsylvania. So
right. Okay. Good. So that would be a way. That would be a source of funding to get a high tunnel, and maybe just I don't know if they would fund it to add on the spore filtering capacity or not in the fans.
Looking for more information about HEPA filters. I think those are widely available filters. HEPA has to do with the level of filtration. So I would suggest just a general web search for more information on HEPA. We did last year, Lou was actually featured in our Farm Innovations Forum as a part of the PASA conference. So we actually had a poster about his farm innovation with a little more detail, a few pictures and a breakout. I will try to pull that out of our archives and include that in the email as well for people to reference, just because it's kind of a neat little thing to include too.
Yeah, Dan, if you could try to also look up the link to his reports. Yeah. On the SARE website, that he's a good report writer, in addition to being a good farmer and an incredible inventor. So yeah, good information there.
Include that link too. Yep. All right. Just a reminder, yeah, for folks, please do look at the chat box and use that link, the pasa.tfaforms.net for the event eval. It'll help us with just assessing how this was. I want to thank Abby for joining us tonight, and we look forward to seeing all of you at a future event, hopefully in person sooner rather than later, but we'll do it the best we can for now. Thank you all so much, and have a good evening.
Thanks, everyone.